Hi, chemistry peeps. I'm here to go over the chemistry gases notes. Let's get started. The first part is just matching what works for pressure, temperature, or volume. So kPAs are what we measure pressure in. So put an A there. C is for temperature because that is degrees Celsius. Okay. And here we have volume because that's supposed to be milliliters. Sorry about that. K is Kelvin. Not Kevin, but Kelvin. So that is temperature. mmHgs, you're not going to see as much, but that is pressure. And atmospheres, ATM, are also pressures. And that's what we normally see, standard temperature and pressure with we use ATMs. But in the problems that we're going to work, we're going to use mostly kPAs. And number 7 is liters, so that is definitely going to be volume. Okay, so complete the following statements by writing decreases, increases, or remains the same on the lines provided. So these are some important things we need to know about gases. So as a gas is compressed in a cylinder, okay, it is very important to know what happens as it's compressed in a cylinder. So you got to think about so what if we're up here and the gas is here, and then we start to compress it down, and then, don't you love these lovely drawings? They're so accurate. Okay, so we're pressing these down. So that's our compression of our gas in our cylinders. So what do you think happens? Okay, now I want to remind you about the law of conservation of mass/matter. Okay, so if it's mass, then it's obviously going to do what? It is going to stay the same. Okay, the number of gas molecules, even as it's being pushed down, those gas molecules aren't escaping the cylinder, so they are also going to stay the same. So what about the pressure? Well, as you can see by the picture, we're increasing the pressure. And the volume, if you look at how much is available of the gas, the volume actually decreases. Now, that doesn't mean we're losing mass. It just means that the gas molecules are closer together. Okay, so the distance between the gas molecules is going to decrease. Okay, now the density, if you look at it, you'll see all those gas molecules are definitely more dense. So that is important. Okay, Boyle's law states that the pressure of a gas is inversely proportional to its volume. So I want you to definitely highlight that. Okay, explain that statement. So let's start with what Boyle's law looks like, and it looks like this: pressure 1 times volume 1 equals pressure 2 times volume 2. So if you increase the pressure of the gas, then the volume will decrease. That's inversely proportional, so that basically means opposites. Okay. All right, complete the following statements about the nature of gases as presented in the kinetic molecular theory. And you do have a PowerPoint on this. If you have not looked at it, please do so by filling in the appropriate word or words from the list below. Okay. Gas particles exert blank on one another. They actually exert no force on each other. Gas molecules are said to be in random motion. And we drew that on our phase change diagram. The volume of gas particles themselves is said to be, technically it's said to be 0. That's a little bit tricky, and we'll talk about that later. The collisions between gas particles are perfectly elastic, which is, I know, a strange saying, but that just means they bounce like elastic, bounces and comes back, bounces and comes back. The temperature of a gas is a measure of the average kinetic energy of the gas particles. Okay, flip it over. All right, match each example below with the appropriate gas property it illustrates. So the fragrance in a perfume spreads across the room. Now, we've all experienced this in class when somebody sprays something. Okay, so it diffuses through other gases. That is a perfect example of diffusion. Smog forms over Atlanta during summer days. That is also actually diffusion. A cylinder of oxygen used in a hospital. That's actually compressed because they're normally in tanks. So that is compressibility. Water boils at a lower temperature at higher elevations. Okay, that's exerting pressure. So that's C. So anything at higher elevations is definitely a game changer. So when you look on, if you ever make box cake, if you read the ingredients and the directions on the cake itself, on the box, you'll see that you even have to change the temperature when you're above a certain elevation. Okay. A balloon, number 24, a balloon inflated with helium actually will fill the container. And we know this with what? Balloons. A balloon filled with air weighs more than an empty balloon. Has mass. Balloon filled with air weighs more than an empty balloon has mass. Okay, I hope that helped. Okay, let me know if you have any questions.